Hello sir, my name is Said Mujawar. My roll number is 47. So today I am here to present the ISO activity of the subject heat and mass transfer. So my topic is design of composite wall for cold storage facility. So the aim of this activity is to design a composite insulated wall for cold storage and calculating its heat gain. So we have to maintain the inside temperature of the cold structure is minus 20 degree and the outside temperature is 35 degree. So the temperature difference will come 55 degrees Celsius. So total wall thickness is 0.20 meter. That is configured into three parts. The first part is the concrete. For concrete, the thermal conductivity is the 1.8 watt per meter Kelvin, and for outside the FRP is 0.15 watt per meter Kelvin. And for middle part, we have taken the two insulation materials. First is the XPS, that is extrude polyethylene. For this, the K value is 0.030 watt per meter Kelvin. And the second insulation material is mineral wool. For this, the K value is 0.040 watt per meter Kelvin. So here you can see. So according to my roll number, the HI value will come the 27 watt per meter square Kelvin, and the HO value will come the 30 watt per meter square Kelvin. So wall area will become the 7.35 meter square. So the wall configuration, as I said, the wall is configured into three parts. The outer layer is concrete, that is 0.05 meter, and the middle layer is of two insulation materials. First is the XPS, that is 0.04 meter, and second insulation material is mineral wool, that is 0.06 meter, and the inner layer is 0.05 meter. Then we have to calculate the resistance. So we have taken the one inside convection resistance, outside convection resistance, and the conduction resistance for the each layer. So outside convection will by the formula 1 upon HA, it will become the 0.01047 Kelvin per watt, and the inside convection will become 0.00503 kilo per watt. And for conduction resistance, first layer is of concrete. So by the formula K divided by A, the resistance for concrete will be, come as a 0.00378, and for XPS, that is the insulation material, the resistance is 0.1815, and for mineral wool, the resistance is 0.2041, and for outside the FRP resistance come as a 0.04535. Next is so now we have to calculate the total resistance. Simply we will first we will calculate the total thermal resistance, that is our total. We will plus all the resistance, and the value will come as a 0.450 T, and then we will calculate the Q by formula delta T upon R total, that is 55 divided by 0.4502. So the Q will come 1 to 2.1 watt, and heat gain per unit area, that is by formula Q divided by area. So the Q value will come 16.6 watt per meter square. So percentage resistance contribution. So each layer will contribute for colder. The XPS will contribute 40%, while the insulation material will contribute 45% and 10%, and the concrete contribute 1%, and convection will be 4%. So insulation layer provides maximum resistance, and hence insulation controls heat transfer. So for the cost analysis, XPS cost is the value will come 320 into 0.4, that is 128 per meter square, and for mineral wool 200 into 0.6, that is 120 per meter square, and the insulation material will cost 248 per meter square. So total wall cost will 1823 rupees. Then the effect of 50% increase in K. So new K value are the for XPS 0.0345, and for mineral wool 0.046 watt per meter Kelvin. So new total resistance by summation of this resistance will 0.403 Kelvin per watt, and the new heat transfer by the same formula. So Q new will come the 136.4. So we will experience the increase in 11.7%. So conclusion for all this, the heat flux without insulation is the 113.5 watt per meter square, and designed heat flux by increasing 50% is 16.6 watt per meter square, and heat reduction is 85%. So the selected materials provide high thermal resistance, economic cost suitable for cold storage. Thank you.